So, what if I told you that one of the biggest industrial waste problems in North America is being solved not with some giant, expensive new machine, but with the very same kind of smartphone that's probably going to be in your pocket next year? It sounds a little like science fiction, I know, but believe me, it is happening right now.
Okay, so let's get right into it. To really get why this solution is so genius, you first have to understand the sheer scale of the crisis that's facing Ontario's industrial sector. Seriously, they're heading for what everyone's calling a waste cliff, and it's a ticking clock.
Now you see this number, 2034. That's the deadline. That is the year when all of Ontario's regional landfill capacity is projected to be completely, totally full. But here's the kicker. The crisis actually starts much, much sooner than that. Yeah, take a look at this. This timeline really lays out the perfect storm that's brewing. I mean, it starts in 2026 when municipalities just stop collecting from their industrial clients, leaving millions of tons of waste completely stranded. At the same time, new trade rules are making it way harder to ship waste to the US. And then, boom, by 2029, just landfilling clean wood could be banned entirely. It's just one domino falling after another. You know, the stakes here really couldn't be any higher. We're talking about millions upon millions of tons of material. And for the businesses in Ontario's industrial heartland, the 905 corridor, the risk of terminal failure is very real. I mean, what do you do when you literally cannot get rid of your waste? So, how in the world do you solve a problem this huge? Well, we're going to break it all down. We'll look at the crisis, the incredible system designed to fix it, the really surprising piece of hardware that runs the whole thing, what it looks like in the real world, and, of course, the financial payoff at the end. Right. The answer here isn't just digging a bigger hole in the ground. It's a total paradigm shift. It's a system called the Digital Refinery, and it's designed to do something amazing: transform this massive liability into a seriously valuable asset. And this image just perfectly illustrates the whole concept. See, on the left, you've got the chaotic, messy, unpredictable world of industrial waste. Then, way over on the right, you have the new bioeconomy, which needs perfectly clean, predictable material to make new products. The digital refinery? It's that sophisticated bridge in the middle, translating all that chaos into pure, usable order.
And it's built on 5 distinct layers. It all starts right at the edge, with AI sorting the waste the second it's collected. Then it uses a super smart logistics model to move it efficiently. There's a regulatory engine that turns raw sensor data into legal proof, a financial system that actually makes sorting profitable, and finally, a reporting layer that spits out all the data for audits and climate compliance.
Okay, now for the big reveal. The hardware that's powerful enough to run this entire industrial compliance and logistics system, often on a muddy, messy construction site, it isn't some $1,000 ruggedized industrial computer. It's this, the Google Pixel 10 Pro. It seems totally backward, right? I mean, why would you bet a critical industrial process on a consumer device? Well, the answer lies in this fundamental shift in how computers are being built, moving away from general-purpose chips to ones that are highly, highly specialized. So here's the most important part. Thanks to its next-gen Tensor G5 chip, the Pixel 10 Pro isn't really just a phone. It's basically a pocket-sized AI server. And it's designed to handle heavy, continuous AI workloads for a full workday, a whole 8 hours without overheating. That's the game changer, because that thermal throttling issue is what makes other phones totally unsuitable for this kind of job. Let's geek out a bit and go down to the chip level. A normal CPU or GPU, it's a generalist. It can do a lot of things pretty well. But the Tensor Processing Unit, or TPU, inside that Tensor chip, it's a specialist. It's what's called an ASIC, an application-specific integrated circuit. That's just a fancy way of saying it's a chip that's physically hardwired to do one thing with insane efficiency, the core math behind neural networks. It doesn't waste power guessing. It's built for the predictable flow of AI. And the secret weapon inside that TPU is this really elegant concept from way back in the 80s called a systolic array. Just think of it like a data factory floor. Instead of one big, super fast worker running back and forth to the parts warehouse, you have thousands of little workers lined up in a grid. Each one does one simple task and passes the result directly to their neighbor. It's like this perfectly choreographed dance that makes it unbelievably fast and power efficient for AI. And of course, all this specialized hardware is managed by an equally specialized operating system. You see, Android 16's AI core acts like a central brain for all the on-device AI. So instead of every single app running its own power-hungry AI model, they just make a request to the OS. This lets the system manage heat and memory for all AI tasks globally, and this is huge. It does it all privately and securely right on the device. No data ever has to leave the phone.
All right, so we've got the specialized hardware, we've got the smart OS. Now let's see what this actually looks like for a truck driver, standing on a messy demolition site, using the 905 Wood app.
The very first and most critical function is what they call the compliance gate. The driver just points the phone's camera at a bin full of wood, and using the power of that TPU, the on-device AI makes a crucial decision in less than 2 seconds. Is this clean, valuable material, or is it potentially contaminated waste? That single step prevents contamination of the entire supply chain. It's huge. Now, once the material is classified, the driver has to finalize the legal manifest. And this is where the user experience is just brilliant. To create a real sense of legal finality, the app uses a hold-to-seal mechanic. The driver physically presses and holds the screen, and the phone's haptic motor vibrates, creating this tactile digital handshake. That one action locks in the chain of custody and generates all the verifiable data needed for the legal paperwork. But the app's AI is doing a lot more than just classification. It's also using computer vision to estimate the weight of the material in the bin. So if it calculates that a load is dangerously overweight, which can happen really easily with wet wood, it flashes this massive, critical warning to prevent super expensive damage to the truck's axle. And here's where that tight integration with Android 16 becomes, well, a lifesaver. The operating system is smart enough to know this isn't just another text message notification. It's a critical safety alert, so it's programmed to completely bypass the driver's Do Not Disturb settings, making absolutely sure that warning is never, ever missed.
Okay, let's switch gears and talk about the payoff. Let's see how all this on-site data collection comes together for the client. Because all of this work is designed to turn what feels like abstract compliance into very real, very tangible rewards, both financial and environmental. All that data flows right into this simple, clean client dashboard. This isn't buried in some complicated spreadsheet. They can see all the key metrics at a glance. A high diversion rate showing how much waste is staying out of the landfill, green check marks confirming they're meeting regulations, and, my favorite part, a running total of how much carbon has been sequestered by their urban forest inventory. But honestly, the most powerful feature might be this idea of levy avoidance. See, in a region where disposal and transportation costs are just skyrocketing, the system clearly visualizes these painful, punitive taxes, in this case, $8,000, that the client would have paid if they hadn't sorted their material correctly. It weaponizes loss aversion, you know? It makes the financial benefit of doing the right thing absolutely impossible to ignore.
And it goes way beyond just saving money on taxes and fees. The system's rigorous, verifiable data trail is so good that it's used to generate these high-integrity carbon dioxide removal certificates, or CORCs. These are basically verifiable proof that carbon has been safely locked away. And they can be sold. This process literally transforms a waste product that was a huge liability into a brand new carbon-negative financial asset.
So what's the big takeaway here? What's the crucial point? Well, this entire system is about so much more than just wood waste in Ontario.
What we're really looking at here is a blueprint for a whole new kind of industrial revolution. It's this perfect mix of Hamilton grit meets Silicon Valley. It proves you can use the power of localized AI running on everyday consumer hardware to solve these incredibly complex, gritty, real-world problems in industries that aren't always glamorous. And this just leaves us with a really provocative question, doesn't it? We've just seen how a regular smartphone can become a legally compliant industrial refinery. It really makes you wonder, what other complex systems are just sitting there, waiting to be completely revolutionized by that little supercomputer that we all carry around in our pockets?